Okay, I haven't made a video in a while, but my students are at home trying to learn by themselves, and I'm going to try to help them. Last week they tried to do stoichiometry by themselves, and I had a video to help with that. So this week is significantly easier. It's the gas laws. It's Boyle's law and Charles' law. So I have those equations right here. Boyle's law is a pretty easy algebra 1 equation. Pressure times volume equals pressure times volume. And it's an inverse relationship. As one increases, the other decreases. So if you put a lot of pressure on a gas, the volume is going to decrease. If you let off on the pressure, if the pressure decreases, the volume is going to increase. So they have an inverse or opposite relationship. Okay? Charles' law is a direct relationship. If you heat up a hot air balloon, the gas is going to expand. If you take a balloon outside and the temperature goes down, the volume is going to decrease. The balloon's going to get smaller. So it has a direct relationship, both increase or decrease at the same time. So Charles' law is also a fairly easy algebra 1 equation. Volume over temperature equals volume over temperature. So you're going to have 3 of those and then 1 unknown, and you're going to cross multiply. However, the temperature, all temperatures for all gas laws have to be in Kelvin. We have to add 273 degrees to the Celsius to get an equivalent Kelvin temperature. Okay, can anybody tell me why we do not use Celsius temperatures in the gas laws equations? Let's see, who can I call on? Stephanie?
Yes.
Okay, why do we not use Celsius temperatures in the equations?
Because Celsius has 0 and negative temperatures and Kelvin doesn't.
Very good. You are my best student today.
That's great.
Thank you. Okay, now to do a couple quick sample problems. So again, Boyle's law, pressure and volume of a gas. I have an example here. 2.30 liters of a gas is at a pressure of 725 millimeters of mercury. What is its volume at standard pressure, which is 760 millimeters mercury? How's my equation going to be set up?
I don't know.
Okay, hold on. You haven't done this in a while. All right. So we've got pressure times volume. So 725 millimeters of mercury times 2.30 liters equals our pressure of 760 times X, so we can find the new volume. Okay, so I have that set up here. There's our equation. We end up with 1,667.5 equals 760 times X. I don't want anyone to make the mistake of dividing backwards. X right now is being multiplied by 760. So we have to divide both sides by 760 to get X by itself. And that gives us a volume of 2.19 liters, our new volume. And again, because one increases and the other decreases, we're getting the pressure increasing, so the volume's going to go down. So you should be able to, roughly check your answer and estimate and see if it makes sense. That volume should be going down like it did, and it should not be going up. Okay? Then I have a Charles' law problem. 600 milliliters of air is at a temperature of 20 degrees Celsius. What is the volume at 60 degrees? So we have volume over temperature equals volume over temperature. 600 milliliters over 20 degrees Celsius equals X over 60 degrees Celsius. Except what do we have to do now? What do we have to do now?
Convert it to Kelvin?
Very good. So we have to, this is a lovely class today. So we have to add 273 to both of those. So this is set up correctly, but you have to add 273 to the Celsius temperatures to make it Kelvin. So if we add 273 to both temperatures, 20 plus 273 is 293. 60 plus 273 is 333 Kelvin. So then we just have to cross multiply. We have 600 over 293 equals X over 333. What two numbers am I going to multiply together first?
163,860 times 293.
Well, where did I get the 163,860 from? How did I cross multiply up here? Because some students forget how to cross multiply, or they still have trouble with it.
600 times 333.
Yeah, we have to do, when you
Yeah.
cross multiply, we have this product equals this product.
Mm-hmm.
So 600 times 333 equals 293 times x. So 600 times 333 is 163,860, and that equals this product, 293 times x. And again, hopefully nobody will be dividing backwards. We have to divide both sides by 293 to get that x by itself. And then that equals 619 milliliters. And then we just need to check and make sure it makes sense. Because again, Charles' law has a direct relationship. Both the volume and the temperature increase together or they decrease together. So we have 600 milliliters at 20 degrees Celsius. We're increasing the temperature to 60 degrees Celsius. That means the volume should go up, and it does. Okay, thank you very much.